It began, as these things often do, with a mystery. The National Zoo's collection of poison dart frogs, a group of amphibians native to tropical Central and South America known for their dazzling coloration, were dying. The young larvae perished just as they transformed from wriggling tadpoles to adult frogs. It can take a while for people to even notice when animals start dying off in nature, but in a zoo there are pathologists, disease scientists, tasked with understanding the cause. One of those pathologists was Alan Pessier. He suspected that a fungus, that weird kingdom of life that includes both edible mushrooms and athlete's foot, was the culprit. But to be sure, he needed help. This was in 1997, a year before Google launched, when the World Wide Web was still stitched together by a patchwork quilt of search engines, Excite, Ask Jeeves, AltaVista. But somehow, Pessier found his way through the tubes to the website of Melvin Fuller, a retired mycologist formerly of the University of Georgia. Pessier and his zoo colleagues sent Fuller some electron microscope photos of the pathogen killing their frogs. Then Fuller sent them to Joyce Loncourt, an associate research professor in biology at the University of Maine with whom he'd informally collaborated in the past. It was a serendipitous connection. Loncourt immediately identified the specimen as belonging to a group of fungi called Chytridiomycota, chytrid for short, that she had quietly been studying off and on for the better part of 3 decades. Pessier had managed to connect to one of just a handful of people with the expertise to identify the killer. And had things gone just slightly differently, she might not even have been there to come to the rescue. Species of frogs, salamanders and toads are all at risk from chytridiomycosis, the disease caused by the chytrid fungus. Loncourt began studying chytrids, microscopic fungi that hang out in water, in 1960. Towards the end of her senior year of college at the University of Michigan. They were not a sexy topic, but curiosity of these critters prompted Loncourt to stick with them through her master's degree at Indiana University, and for a stretch after she got married and relocated to Maryland. All the while, she was doing the sort of classification and observation study that is the bedrock of basic science, and the bane of those who seek immediate returns on scientific investment. There wasn't any obvious benefit to studying these fungi, beyond increasing our understanding of our world. When Loncourt started to have children, she stopped working. I belonged to a different era, she says. Women were switching from staying at home to going to work. I stayed home, and there was just never any question in my mind about doing otherwise. I wasn't a person who could manage shuffling kids off to daycare and going to a job. Nor did I want to. A couple of decades later, a request came from a researcher in Orono, the Maine college town that Loncourt now called home. She'd received an NSF grant to study the function of domestic leach field for sewage, and had been referred to Loncourt for assistance. She came and convinced me that I still knew more about this group of fungi than she did, and that I could help, says Loncourt. So Loncourt went to work in the lab part-time for about 6 months. But once she was back behind the microscope, she knew it was where she needed to be. Loncourt enrolled in a PhD program. As a master's student in the 60s, it was the norm to simply draw diagrams of the organisms you studied. As a PhD student in the 80s, Loncourt learned all about electron microscopy, which uses a beam of electrons to create an image of a specimen. She learned how to grow fungi in pure culture, and how to photograph and read photographs of specimens. Her time away had opened up a whole new world of possibilities in understanding the tiny organisms that had always fascinated. But when she graduated in 1991, her attempts to get the sort of National Science Foundation grants that fund most scientists' work failed. With no obvious payoff, work on chytrids wasn't high on anyone's priority list. I said, to heck with that, Loncourt says. Instead of wasting her time endlessly applying for NSF grants, she decided to make do with what little money she could get from other sources. And that's where she was when she received Pessier's electron microscope photos in 1997, toiling in an unused corner of someone else's lab, isolating fungi and publishing papers. The chytrid Pessier had isolated from the zoo's dying frogs was immediately identifiable to her. That was really weird, because at the time we did not know of any other fungus from this group that was a pathogen of vertebrates, she says. We knew that they could be parasites of algae or invertebrates, but we didn't have any idea of any of them being a pathogen of an amphibian. It turns that sheet rid can and do infect frogs, toads, and salamanders.